Good afternoon, everybody. I am Hasna Yerzan, a PhD student at the University College London. In this work, we examined regional brain volume and neuropsychological differences in a cohort of extremely preterm adolescents compared to their age and socioeconomically matched peers. So first, let's define where extreme preterm birth lies with respect to normal birth. While the normal period of gestation is at least 37 weeks, extremely preterm born subjects are born before 27 weeks of gestation. In a report of 2010, the World Health Organization estimated that globally, prematurity is the leading cause of death in children under the age of 5 years. However, in developed countries, better socio-economic factors and improved neonatal care increased survival rate after preterm birth. What really is the challenge now is that increased survival rate has not been associated with substantial decrease in neonatal morbidity and prevalence of poor cognitive performance, as found by a UK-based study of 2012. Previous neuroimaging studies on preterm subjects have regularly reported higher risk of poor cognitive outcome and developmental abnormalities throughout the brain volume, especially a loss in the gray matter. Despite the research effort in investigating preterm newborns and infants, very few studies have investigated structural brain alterations in extremely preterm subjects, especially when these subjects are adolescents. So for this reason, this study aims to analyze the difference between the regional brain volume of extremely preterm subjects and full-term born subjects. Besides, because there are some studies suggesting a worse outcome for male subjects born preterm, we test the hypothesis that the effect of premature birth on brain volume depends on whether one is male or female. Moreover, we investigate the hypothesis that the volume of gray matter regions where significant group differences are found would relate with the cognitive outcome. So the following linear model interprets the relationship between the volume of a brain region, here indicated as RBV, the total brain volume, here indicated as TBV, sex and birth state. The increase in TBV is linked to an increase in the volume of RBV. RBV and TBV are log transformed to account for potential nonlinearities. Dummy variables are used to moderate the effect of other explanatory variables such as sex and birth state. The gap in expected regional brain volume between extremely preterm and full-term females is estimated by beta 1, while the gap in expected regional brain volume between extremely preterm and full-term males is beta 1 plus beta 3. Therefore, the coefficient beta 3 estimates the extent to which the effect of being extremely preterm born differs for male and female sample members. So, the overall total brain volume of extremely preterm born males is significantly lower than the total brain volume of the full-term born males. Similarly, the total brain volume of the extremely preterm born females is significantly lower than the total brain volume of the full-term born females. So here, the figure on the right shows the amount by which the volume of each brain region has changed in the extremely preterm subjects, encoded with the beta 1, and the additional changes due to the male sex encoded in beta 3. The values here are given with respect to the reference group, which is the full-term born females. The figure on the left shows the statistics of the coefficients beta 1 and beta 3. So overall, we notice that the subcortical structures, including bilateral thalamus, bilateral pallidum, bilateral caudate, bilateral amygdala, bilateral hippocampus, left parahympical gyrus, and right subcortical area, are significantly reduced with an average of 8.23%. So the brain regions that are significantly increased in the extremely preterm subjects are distributed in the medial prefrontal cortex with an average increase of 10.26%, anterior medial cortex with a mean rise of 10.25%, bilateral middle frontal cortex with a mean increase of 8.43%, and regions in the occipital lobe with a mean rise of 10%. The coefficient beta 3 of the interaction effect shows that the bilateral temporal pole, cerebellum, cerebellar vermal lobules, and left fusiform gyrus are significantly reduced in the extremely preterm males. So, overall cognitive ability was evaluated using the Wechsler abbreviated scale of intelligence, the second edition. As you can see here, there is a significant difference between the extremely preterm subjects and the full-term participants in terms of IQ performance. Although there is no statistically significant difference between males and females in each group, the extremely preterm males achieved lower mean score than the extremely preterm females. The contribution of the regional brain volumes with significant between group or sex differences to the neurodevelopment outcome is analyzed using stepwise linear regression. The full-scale IQ scores denote the dependent variable, while the gray matter volume and the group or sex membership are the regressors. So the results of the stepwise linear regression comparing extremely preterm and full-term born subjects revealed that the premature birth and the volume of the left precuneus and right posterior cingulate gyrus region in which the extremely preterm showed greater regional volume than full-term subjects. Those areas account for 34% of the variance of the IQ score, with the group membership accounting for 21.8% of the variance in IQ scores. The stepwise linear regression comparing extremely preterm males and females showed that 6 differences in the extremely preterm subjects and the volume of the cerebellar vermal lobules and the right temporal pole account for 23.5% of the variance in the IQ. So we examined regional brain volume differences in a cohort of extremely preterm adolescents compared to their age and socioeconomically matched peers. We controlled for total brain volume and sex and investigated the impact of extremely preterm birth on the volume of gray matter structures. The findings of the present analysis suggest that extremely preterm adolescents still lag behind their peers as the brain differences and poor cognitive outcome persists. Like other studies on very preterm individuals in mid-adolescence, our analysis showed both smaller and larger brain structures. The consistency of these findings suggests that these regions might be especially vulnerable to damage and that the extremely preterm subjects would endure long-lasting or permanent brain alterations. The loss in gray matter content might be a secondary effect of white matter injury, as white matter damage is linked to gray matter growth failure. Larger gray matter volumes in extremely preterm subjects might reflect a paucity of white matter content or, as proposed by other authors, a delayed pruning process. It is also worth mentioning that the results showed here suggest that status of being male and born extremely preterm results in a reduction in bilateral cerebellum and temporal pole volume. Although this result did not persist after the adjustment for multiple comparisons, it is worth considering these results for future analysis. Overall, however, it's hard to conclude if the observed volume abnormalities are growth lag or permanent changes. To investigate this, further investigations on this cohort or similar cohorts need to take place at later stages of life of these subjects. I'd like to thank these institutions for their support, and thank you.